Hi, my name is Abdelatif.
And I'm Ryan Bronson, and this is Intermediate Optics Lab 8, Interference by Division of Amplitude. An idea of the Michelson interferometer is to observe interference by division of wavefront. Using the beam splitter, the light source will split into two beams where each of those beams will reflect off of a mirror and head back towards the beam splitter, which will then combine their amplitudes, and a cosine fringe pattern should be observed.
The two distances we need to consider in this lab are the distance from this mirror to the beam splitter and this mirror to the beam splitter. When you change one of these distances, you will see a difference in fringe width.
In portions, it just means that your patterns are not.
Here we can see that as the mirror changes in optical path distance, we move from 0 OPD to larger OPD, the fringe spacing becomes smaller.
The geometric orientation of the fringe pattern in the XZ plane can be explained by the following diagram and equations. The center spot is caused by source 1 since the source propagates parallel to the z-axis. The different modes will create the fringe pattern, but the 0 mode will never be seen because it's parallel with the XZ plane. The interference between the two sources will project onto the observant screen, and the distance between the two sources will determine the fringe width and will also change the optical path distance. Because the optical path distance also determines where the bright fringes are seen, this will in return change the bright fringe spacing on the observant screen.
So when we look at the orientations of the two mirrors, this one being the reflected image of mirror 2, this one being the physical mirror 1, when their tip and tilt is adjusted accordingly, we're going to see cosine straight line fringes, also known as fringes of equal thickness.
As the OPD decreases, meaning the micrometer is moving from larger to smaller, we see that the fringes will become more straight.
So white light fringes are only visible when our OPD is 0. You can tell our OPD isn't exactly 0 here because we can see other colors. In this picture, you can tell as our OPD is increasing from our 0, our wavelengths are going to start to become more and more defined, and they will eventually combine to create white light.